This is ISM page 37 when we are done. Inverses are not brand new to you. You have found inverses before, algebraically and graphically. Probably have not talked about the domain. I believe that's kind of the new part to this. So, what is the inverse of a relation? So we're going to talk functions in just a minute, but we're talking relations right now. The inverse of a relation is a relation that exchanges x and y and is a reflection, looks like one word, a reflection in the line y equals x. Okay, so algebraically it exchanges x and y. Graphically it's a reflection in the line y equals x, which is the linear parent function. Okay, so our notation, which we don't do a whole lot with relations really, but this still is good for you to know. Relation R, which is like a capital italic R, is written as R inverse. Looks like a little exponent of a -1. It's exactly where an exponent would go, but it's not an exponent. So then when I want to give the inverse, they give me R. I need R inverse, and this is just a list of ordered pairs. So all we're doing is exchanging x and y. So 0, -7 becomes -7, 0. Then -1, 2 becomes 2, -1. Then -4, -2 becomes -2, -4. And 6, 3 becomes 3, 6. It's that easy. Along with inverses goes one-to-one functions. Okay, so a function has a one-to-one relationship, bless you, is a one-to-one relationship if the relation and its inverse are both functions. Okay, so a function has a one-to-one relationship if the relation and its inverse are both functions. So you have to have a function, you find the inverse, the new one is a function also. That gives it a one-to-one relationship. Okay, so recall, meaning we already know this and we've already talked about it, that a vertical line test is used to determine whether a relation is a function when you're given a graph. We have a new test, which is just as easy as the vertical line test. It's called the horizontal line test. It's used to determine whether the inverse of a relation is a function. So without actually finding the inverse, we can figure out if when we do find it, whether or not it would be a function. Okay? So both the relation and its inverse must be a function in order to be a one-to-one function. Here's a little funny story side note. One-to-one is not 1, 2, 1. Miss Ludicky down the hall is in room 121, and she gets students all the time that were sent to the one-to-one room, and they have no idea what the one-to-one room is or what that means, and they end up in her room, and she has to direct them to the dining hall. So anyway, one-to-one, totally different concept. Okay, so all we're going to do here is with a graph, very easily, just like the vertical line test is super easy, the horizontal line test is super easy. So when we look at number 1, does it pass the vertical line test? Yes, absolutely. Does it pass the horizontal line test? Yes, so that tells you it's a one-to-one function. Yes. So I have a function. If I found the inverse, it would be a function also. Okay. Number 2, does it pass the vertical line test? Yes. Does it pass the horizontal line test? No. So this is a function, but it's not a one-to-one function, and if I was to find the inverse, it would obviously not be a function. Right? Number 3, does it pass the vertical line test? Yes. Does it pass the horizontal line test? Yes. So it is a one-to-one function. Number 4, pass the vertical line test? Yes. Horizontal line test? Yes. Number 5, pass the vertical line test? Yes. Pass the horizontal line test? No. Fails it miserably. Right? I don't think it could fail it any worse than it did. All right, number 6, pass the vertical line test? Nope. Does it pass the horizontal line test? Yes, but the answer is no, because since it fails one of them, it's not a one-to-one function. Okay. Easy enough graphically? Yes? All right, so let's look at it algebraically. So inverse functions. So when you talk about f of x, the inverse of f of x is f inverse of x. And again, it goes where an exponent would go, but it's not f to the negative 1 power. Not all functions have inverse functions. I mean, we just saw that on the other side, right? So to find the inverse, here are your steps. You replace f of x with y. Interchange x and y. Solve for y. Rewrite y as f inverse of x. Okay? That's how you actually find it. But then it also says state any restrictions on the domain. So let's talk about how we do that. We're changing x and y. Every single x and every single y just boop, switch places, right? So that means the domain and the range, domain is x, range is y. They stay what they are, but they switch places also, right? The range becomes the domain becomes the range. So if I want to know what the new domain is, I need to think about the range of the original function. So for f here, this is linear, right? So I can think of it either as, let's see. So the parent function looks like this. Sometimes it's helpful to do a really quick sketch of what this kind of would look like. Like that's a linear. We can graph that pretty easily. What's my y-intercept? -8. So the line really looks something like that, right? Probably not to scale. My slope isn't exactly right, but right, something like that. And really with either one of those, the domain and range are the same, right? It's negative infinity to infinity. So since the range here is negative infinity to infinity, there's no restrictions on my new domain, so I don't have to state it, because it doesn't say I have to state the domain, it says state any restrictions. So if there's not any restrictions, we don't have to state anything. Okay? We'll look at somewhere we do have restrictions. All right, so let's see. We've done that. We're going to replace f of x with y, and then we switch x and y. So that's going to give me x equals 4y minus 8. Then I very simply solve for y, which some people had a very big problem with on that first test. I'm going to add 8, so I get x plus 8 equals 4y. Divide each term by 4. So that's going to give me 1/4 x plus 2 equals y. So f inverse of x is equal to 1/4 x plus 2. Okay. Any questions at all? Sound familiar? Okay. All right, so let's look at number 8. We're going to look at our parent functions or our little sketches 2 different ways, because I want you to see why understanding what the transformations are doing can be very helpful to you. My parent function for a cubic looks like this, right? My transformations are that it gets vertically compressed by 1/2 and it gets shifted down 1, right? So that one looks something like this. So I can easily make a sketch of the actual function also. Not saying you'd always have to do both, but we're going to kind of do both to see which ones might be more helpful with what we're doing. I didn't make any little hash marks, nothing. I just needed kind of the general idea of what was happening with it so I can figure some things out. So once again, the range of my original function is negative infinity to infinity. So the domain of my new function is not going to change. I'm going to change f of x to y, and I'm going to switch x and y. So I get x, can somebody, don't turn that off. X equals 1/2 y cubed minus 1. Then I'm going to add 1 to both sides, so x plus 1 equals 1/2 times, oops, I need the parentheses, I don't know why I'm doing that, y cubed. Okay, so what would I do next? Multiply by 2. So I'm going to get 2 times x plus 1 equals y cubed. And I'm not going to distribute, and I'm going to show you why in just a second. It's not wrong if you do. You just definitely wouldn't do it at that step because you don't want to distribute wrong. But you could in the next step, but I'm not going to. So the next thing I'm going to do, I have to undo the cube. How do I do that? Cube root. So I take the cube root of both sides, so that'll give me the cube root of 2 times x plus 1 equals y. Do I need a plus or minus or anything? No, you only need that for even roots. I do not need that for odd roots because I can't, they work out differently. So now that I have that, that's my new y. So f inverse of x is equal to the cube root of 2 times parentheses x plus 1. Okay. So once again, I could have distributed and I could have the cube root of 2x plus 2 and that's fine. But if I need to graph this, I want it in that form so I can see my transformations, right? I just have to factor it right back out to graphs, so might as well just leave it like that. Okay, we good? Any questions? All right, let's look at number 9. Okay, so number 9, we've got, this is a quadratic, so it's going to look like this, right? This means I go to the right 4 and up 6. It's actually going to look something like that. Do I even need to start by switching x and y and doing all that? Why not? I have restrictions, okay? Does this have an inverse? Oh, it has an inverse. Is this a one-to-one function? No. So it passes the vertical line test, it fails the horizontal line test, so I can just say no inverse function. It does have an inverse, but it's not an inverse function, and we're talking functions here. It fails the vertical line test, so I don't even have to do anything. Okay. And then we're going to skip number 10 because we haven't graphed those yet. We're going to move on to number 11. Okay, so this is a square root function. It looks something like that, right? My transformations, I reflect an x, move to the left 2, and down 7. So if I move to the, oops, I'm just going to extend that some. If I move to the left 2 and down 7, and I reflect in the x-axis, it's going to look something like that. You agree with that? Now, this range does not have, is not all real numbers. Remember, we want to look at the range of the original one so we can talk about the domain of the last one, or of the inverse. So the range of this function, where does my range start? Negative infinity. My range starts at range is the y, negative infinity to negative 7. Bottom to top, least to greatest. That's your range of f. It does not go from negative 7 to negative infinity. That does not make any sense. Okay, everybody okay with that range there? Yes? Okay, so now we're just going to hang on to that. We're going to do the inverse, and then we're going to come back and look at how all that works. All right, so I'm going to change this to y. Then I'm going to get x equals negative square root of y plus 2 minus 7. Okay. So I'll add 7 to both sides. I get x plus 7 equals negative square root of y plus 2. Okay. I'm going to multiply both sides by that negative, so I get negative x plus 7 equals the square root of y plus 2. All All right, so now I'm going to square both sides. When I square this, it becomes positive. I mean, I could leave it in there, but it really doesn't matter. So I get x plus 7 squared equals y plus 2. So x plus 7 squared equals, oh, sorry, minus 2. Minus 2 equals y. Mm-hmm. Well, you can, but you don't need to, so I'm not. Yeah, it's easier if you don't. So f inverse of x is equal to x plus 7 squared minus 2. Oh, there we go. So there's my inverse. Now let's think about what that looks like. That's a quadratic, right? I'd move to left 7 and down 2. I got that. Does this look like the inverse of this? It doesn't, does it? No, not at all. That's why we have to have a restriction here. If I take this part right here, which was like that, right? That was our f. And we want to reflect it in the line y equals x. Well, when I do that, all I really get is this right here. Does that make sense? When I reflect this in here, I get this. This was the range of the original one. It becomes the domain of this one, negative infinity to negative 7. And that's what this domain right here is. But understanding that we can just switch the domain and range, and understanding the range of the original, I don't have to overthink all that in the end. I want to show you why it works, but you have to have that restricted domain, because that quadratic and the square root don't match up exactly. Okay? What questions you got? Okie dokie. So let's look at 12. My parent function looks like this. When I reflect it and move it, it looks something like this. What's my answer here? No inverse function. Questions? All right. 13. So I've got a cube root. Looks something like that. I know that that 9 means that I move to the right 9. What is that 4 going to do? Stretch it vertically? Compress it vertically. Good. It's like multiplying that by 1/4, right? So it's a vertical compression. Either way, it's going to look something like that. Okay. So your range of this one is negative infinity to infinity. So I don't have to worry about that in the end. Okay. So I change this to y, and I get x equals the cube root of y minus 9 over 4. Okay? You finish that one. Now, did any of you make that 4x cubed into 64x cubed? It's okay if you did, but you totally could, and it wouldn't be wrong. Okay, if I actually cubed the 4, I'd have 64, but there'd be no parentheses anymore, right? I'd have 64x cubed, which means I'd have a vertical stretch by 64, right? If I leave it like this, I have a horizontal compression by 1/4, and they do the same thing. Okay, so it really doesn't matter either way. You'd have the exact same function, and I don't have any restrictions. Okay. All right, so let's look at this. So this function here is a quadratic. Oops. Okay, there's my parent function. But notice it's not the whole quadratic. It has a domain restriction on it. My transformations here are that I stretch it by 3 and I move it down 1, but x has to be greater than or equal to 0, so I really only have this part here. Is the part that I'm working with a one-to-one function? Yes, okay, which means I can move forward, but my range, the range of my f, this is the f of x, not the inverse. What is this range? Oops. The range, -1 to infinity. Okay. The domain is 0 to infinity, but we don't care about the domain right now. Okay? I mean, we care about it because we needed it to figure out that it worked. But okay, so now we're going to make this into y. So we're going to get x equals 3y squared minus 1. So I'm going to add 1 to both sides. I'm going to get x plus 1 equals 3y squared. I'm going to divide both sides by 3, and I'm going to get x plus 1 over 3 equals y squared. So I'm going to take the square root of both sides. I'll get plus or minus the square root of x plus 1 over 3 equals y. Okay? So a couple of things here. Make sure that when you have this, okay, I mean, some of you have some crazy bad handwriting and some crazy sloppy work, and that's not always, that's fine some of the times as long as somebody can read it. But you have to be careful on specific things, like make sure that this square root actually shows that the 3 is underneath it. Okay? And we really shouldn't leave a square root in the denominator. So I could separate it, because I could separate this into the square root of x plus 1 over the square root of 3, and I could rationalize, or I can rewrite what's on the inside right here as plus or minus the square root of 1/3, and then I'd have to have x plus 1 in parentheses, right? Because those parentheses matter, because you're dividing the whole thing by 3. So then that's totally fine, and that is equal to f inverse of x. Do I have a domain restriction this time? Yes, I do, because the range of the original one becomes the domain of my new one, and the domain goes from -1 to infinity. Because what happens is this thing reflects up like this. Okay. What questions you got? We all good? Awesome.